So I'm just gonna show an extremely simple example of how to run a Beam pipeline via Hop. Um, in a nutshell, as you can imagine, it's pure magic. You can mainly reuse steps as you know and trust them. You don't have to think in any special new button like you had to do back in the days of MapReduce. You just create pipelines or transformations, as they were called in the old days, as you know them. Basically, there's not so much to worry about. I mean, you need to have a very basic understanding of how a beam pipeline works, how a stream of data works, but that's really minimal. So getting started with everything is extremely easy, I'd say. So Hop lends itself very well to testing the work as you progress. So for those who haven't seen Hop the Go yet, so you can just easily add your transforms, as they are now called, previously called steps, to the canvas, link them up. And as you do this, you also want to, of course, validate if your logic is working. And thanks to the now properly built-in unit test support, that works amazingly well. So the way this kind of is put in scene is, so here we see we have a beam input and the beam outputs transform. So if I'm within the Hop GUI, this kind of won't work because I'm not really connected to anything. So by using a unit test, I can assign data sets to the input and output, which will basically kind of override them. So you can see here by the gray label that I've already done this. So input data set and the output data set. So the way you should think about it is don't leave it till the very end. So when I started creating this pipeline, already when I added beam input, at the same point in time, I added the synthetic input data set. It's just a simple CSV file that can be read in. You can define this all via the new section here. So you can define a data set, and then you can attach it to any input or output transform. So usually within your Git repo, you'd have one folder where you store these files. At least that's how I do it. So whenever then I open this pipeline, they are ready, and if I have to introduce any changes, I can retest everything, and it just works nicely, hopefully. So going back to what I started with here, so when I add the step in the beginning, I already add the data set, and right away I can then also use the preview to know what's going on. So basically, transform by transform, I validate the logic, and I can understand if it breaks or not. So that kind of gives you instant feedback, which sorts out the problem straight away. You don't have to wait for later until you upload it to your wonderful cloud platform, which makes debugging really a lot easier. So then when you're kind of at the last transform at finally the golden data set, and then you can just run the pipeline, and what it will do is in the end it will spit out in the log if the unit test passed or not. So you could set up a unit test up here, a pull down menu where you can select the unit test. So one suggestion that I made, because to me it's a little bit not really intuitive to run a unit test via the normal kind of run button. Ideally, I'd like to have next to the unit test a run button, specifically to execute the unit tests. Otherwise, it gets a little bit confusing to me where the borders are between normal runs and unit tests. Anyway, just a suggestion. So this is really nice built-in unit testing support, and we can apply best practices by creating a unit test straight away from the beginning, meaning that we can find problems fairly early in the process, which then avoids a lot of headaches. So that's this, and the other bit is, of course, the improved support for environments, which is now really another great feature about Hop. So a lot less headache there. Right, so we've kind of now created our pipeline, we've run the unit tests, everything seems lovely jubbly. So the next step then in the process is to run it locally. So out of the box, Hop also comes with Beam functionally built in, so you can use something called a local runner. So you can create via a new run configuration, and then pick here, Beam Direct pipeline is actually called, and configure that, which basically, as the name indicates, we will run the whole process locally. So now I've done that already, and yeah, let's just execute this. So where is it? This one here. So we kick it off. It's fairly fast. As you see at the bottom, there's already here how many rows were processed and so forth. And you get the standard logging with it. So this now ran via the local Beam engine, so not via the Hop one, but the Beam one. And that's a really nice and quick way to make sure that it's working. So we kind of, to summarize, we kind of had two steps here. First, we tested it via a unit test. The next step was then to run it via Beam's local or direct engine, as it's called. So now we are full of confidence, we are happy chappy, and we want to run our pipeline now somewhere up in the cloud with one of the famous providers. So in my case, I just ran that via Google Cloud Platform, who are, by the way, the original donator of the code. Again, since we are running it somewhere else, we can or should create the run configuration, this time picking Beam Data Flow pipeline engine. And since we're already here, the beauty of Beam is really that you can run it across several engines. So the wonderful idea of creating the pipeline once and running it on multiple engines. So currently Dataflow, the Direct Engine, Flink, and Spark are supported, which really gives you a lot of options here. So it's great that Hop could use an open source project which is supported by many big companies out there, which gets a tremendous amount of contributions, has a lot of development going on, and that this all could be so seemingly easily integrated. In my humble opinion, this is, I think, one functionality that will definitely make Hop a favorite tool for a lot of people, hopefully in the future. It's I think a great, well, probably calling it a selling point is not the right term, but you get the idea, for Hop. Right, so enough words. We can kick it off here. Pick the right run configuration and so on. I won't kick it off right now, but I'll show you over here what's happening. So when you go online then to the GCP console, basically under the hood, Hop translates it into the proper beam transforms. You get this nice graph here of your pipeline. You can, well, expand it. You get some stats here on the side, and also the logs at the bottom. So an overall log, and then you can also drill down by transform. Takes a bit to load, so I will cancel that. The great thing about Dataflow is that it's not just simple beam service. It does all the scaling for you and applies some additional performance improvement logic under the hood as well. So you can kind of don't have to worry on how to scale the process, which is really nice. Few of you, or probably most of you, will remember using Carter to scale our then jobs and transformations, where in some cases we had to add some extra logic to make it work in a big setup. All this is kind of not required anymore. You just design your pipeline and then send it off to, for example, Dataflow, and it's all taken care of for you without adding any additional code. And I think that is a big advantage. Sure, it's not for free, but I think overall probably a small price to pay. And get nice logging and so forth with it. Right, so we have our stats here. It's working, it's running. So that's kind of it in a nutshell. I've started playing around with a few other things, like sending data to, I can show you. They are all still very simple. Sending data to GCP PubSub topic, so streaming it through there and then picking it up on the other side and writing it into BigQuery, but currently the second bit is still a bit buggy, so I can't quite progress on this. But overall, it's a great feature set to play with. So I'd say, I mean, clearly by now you must be utterly excited to explore everything. Go out, build a few examples and provide feedback so that any bugs can be, found and fixed rather quickly, and that we all explore and enjoy the new great world of Beam. If you want to read up on this, there's my blog post as well, which speaks you through the example. I hope you enjoyed it.